Dear students, welcome to my classroom. In previous class, we completed all the problems in exercise 11.1. And in this class, we are going to find the trigonometric ratios of some specific angles. Trigonometric ratios of some specific angles. That is, we are going to find the trigonometric ratios for some specific angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Let us start with 45 degrees. Let ABC be a right angle isosceles triangle in which angle B equal to 90 degrees. As triangle ABC is right angle isosceles triangle, the sum of angles A and C is 90 and they are equal. So that angle A equal to angle C is equal to 45 degrees. Assume that the length of the equal sides be A units. That is AB is equal to BC is equal to A units, like this picture. Now, from Pythagoras theorem, we have AC square is equal to AB square plus BC square. That is A square plus A square, which is equal to 2A square. From this, we can write AC is equal to root 2 into A units. So, in this picture, AB is equal to BC is equal to A units, and the length of the diagonal AC is equal to root 2 into A units. Students, now from this triangle ABC, find sine A. And we know that sine A is equal to opposite side to A by hypotenuse. Here the opposite side is BC and the hypotenuse is AC. So BC by AC, and we have BC is equal to A and AC is equal to root 2 into A. So that BC by AC is equal to A by root 2 into A. By cancelling A, we get sine 45 degrees is equal to 1 by root 2. So in this way, we got the value of sine A, that sine 45 degrees is equal to 1 by root 2. And cos A is equal to adjacent to A by hypotenuse, that is AB by AC. And we have A is equal to 45 degrees and AB is A and AC is root 2 into A. So that cos 45 is equal to, by cancelling A, we get cos 45 is equal to 1 by root 2. And also tan A is equal to opposite by adjacent, that is BC by AB. So tan 45 degrees is equal to root 2 into A by root 2 into A, which is equal to 1. So in this way, we got sin A is equal to 1 by root 2, cos A is equal to 1 by root 2, and tan A is equal to 1. And the multiplicative inverses of all these trigonometric ratios are cosec A, that is cosec 45, is equal to multiplicative inverse of sin 45, that is root 2 by 1, which is equal to root 2. And multiplicative inverse of cos 45 degrees, that is sec 45 degrees, is equal to, again, root 2 by 1 is equal to root 2. And the multiplicative inverse of tan 45 degrees is equal to cot 45 degrees is 1. Okay, students. So these are the trigonometric ratios of the angle 45 degrees. And next, let us see the trigonometric ratios for 30 degrees and 60 degrees. So let ABC be an equilateral triangle like this. So as ABC is an equilateral triangle, angle A is equal to angle B is equal to angle C is equal to 60 degrees each. Now draw a perpendicular AD from A on BC. Here assume that the side AB and BC and AC is equal to 2A units. Now draw the perpendicular line AD from A to BC like this. In an equilateral triangle, the altitude from a vertex divides the opposite side into two equal parts. That is, altitude divides the side into equal parts. That is bisects. So here AD bisects BC. And also AD bisects the angle at A also. So AD bisects angle A as well as the side BC. So then picture becomes like this. Here the AD bisect the angle A. So 60 degrees divided into two equal parts 30 degrees, and 2A divides into two equal parts A. Now in triangle ABD, take this triangle ABD. In this triangle, AB is equal to 2A, BD is equal to A, angle B is equal to 60 degrees, angle A is equal to 30 degrees, and angle D is equal to 90 degrees. Now from this triangle, AD square by Pythagoras theorem, AD square is equal to square root of AB square minus BD square. That is, we have AB is equal to 2A and BD is equal to A. So 2A whole square is 4A square. So that AD is equal to under root 3A square, which is equal to root 3 into A. So in this way, we got AD is equal to root 3 into A units. That is the altitude of this equilateral triangle whose side 2A is root 3 into A. Okay. Now sine B. From this triangle ABD, take sine B. Sine B. So sine B is equal to opposite side to B by hypotenuse. Here the opposite side to B is AD and hypotenuse is AB. So sine B is equal to AD by AB. Now substitute the values of AD and AB. That is AD equal to root 3 into A and AB equal to 2A. B is equal to 60 degrees. So sine 60 degrees is equal to root 3 into A by 2 into A. So by cancelling A in numerator and denominator, we get sine 60 degrees is equal to root 3 by 2. Also, cos B is equal to BD by AB. Again, substituting the values of B, BD and AB, we get cos 60 degrees is equal to A by 2A. So by cancelling A, we get cos 60 degrees is equal to 1 by 2. In the same way, tan B is equal to BD by AD by BD. So that tan 60 degrees is equal to root 3 into A by A. That is root 3. So students, here we got the trigonometric ratios for the angles 60 degrees. Sin 60 is equal to root 3 by 2. Cos 60 degrees is equal to 1 by 2. Tan 60 degrees is equal to root 3. Now the multiplicative inverses of these trigonometric ratios. So multiplicative inverse of sin 60 degrees is cosec 60 degrees is equal to 2 by root 3. And multiplicative inverse of cos 60 degrees is sec 60 degrees, which is equal to 2. And multiplicative inverse of tan 60 degrees is cos 60 degrees is equal to 1 by root 3. So again from this picture, take sin A. Sin A. Sin A is equal to opposite side to A by hypotenuse. In the triangle ABD, opposite side to A is BD. So sin A is equal to BD by hypotenuse AB. Again, substitute the values in the place of A, BD, and AB. So here the angle A is equal to 30 degrees. So that sine 30 degrees is equal to BD is A and AB is 2A. So sine 30 degrees equal to, we get 1 by 2. Similarly, cos A is equal to AD by AB. That is cos 30 equal to root 3 into A by 2A, which is equal to root 3 by 2. And also tan 30 degrees is equal to 1 by root 3. And the multiplicative inverses of sine 30, cos 30 and tan 30 degrees are respectively cosec 30 degrees is equal to 2 and sec 30 degrees is equal to 2 by root 3 and cot 30 degrees is equal to root 3. So students, here the values of trigonometric ratios for the specific angles 30 degrees and 60 degrees. Okay. Now, let us find the trigonometric ratios for 0 degrees and 90 degrees also. Suppose a segment AC of length R, is making an acute angle theta with the ray AB like this. Okay, this is the ray AB and AB is the segment which is making an angle theta with AB. Height of C from B is BC. Okay, this dotted line represents the height of C from B. Now, if AC leans on AB like this, the length BC decreases gradually as well as the angle theta will also decreases like this. Okay, again see. In this way, as AC leaning on AB, theta decreases gradually and becomes 0 when AC fully laid down on AB. Then the distance AC is equals to AB and BC becomes 0. Okay. So in this triangle ABC, angle B is equal to 90 degrees. If, and also, sine theta is equal to opposite by hypotenuse, that is BC by AC. If theta becomes 0, that is if AC fully laid down on AB, then AB and AC will be equal to R. And the height BC becomes 0. Now, sine 0 degrees. Sine 0 degrees. Here the theta is equal to 0. Sine 0 degrees is equal to, here we have sine theta is equal to BC by AC. And then substituting theta is equal to 0 and BC is equal to 0 and AC is equal to R. We get sine 0 degrees is equal to 0 by R, which is equal to 0. And again cos 0 degrees, that is cos theta. Cos 0 degrees is equal to adjacent by hypotenuse, that is AB by AC. Here both AB and AC are equal to R. So that cos 0 degrees is equal to 1. And also tan 0 degrees is equal to opposite by adjacent, that is BC by AB. Here we have BC equal to 0 and AB is equal to R. And we know that 0 by something is equal to 0. And cosec 0 degrees. Cosec 0 degrees is the side opposite to 0 degrees by hypotenuse. That is the side opposite to, hypotenuse by the side opposite to theta. So here the hypotenuse AC and the side opposite to theta is BC. So AC by BC, but we have here BC is equal to 0. So cosec 0 degrees is equal to AC by 0. But the division with 0 is not possible. So the AC by 0 is an undefined value. And also sec 0 is equal to inverse of cos 0 AC by AB, that is R by R, again equal to 1. And cot 0 degrees is equal to AB by BC, which is equal to R by 0. Here also R by 0 is an undefined value. Okay, students. So we got the trigonometric ratios for 0 degrees. Sin 0 degrees is equal to 0. Cos 0 degrees is equal to 1. Tan 0 degrees is equal to 0. Cosec 0 degrees is equal to undefined. Sec 0 degrees is equal to 1. Cot 0 degrees is equal to also undefined. And we have sin 0 degrees is equal to 0. Cosec 0 degrees is undefined. That is inverse of 0 here we are taking as undefined value. Inverse of undefined value is 0 and inverse of 0 is we are taking as undefined. Okay. And let us find the ratios for 0 degrees also. Okay. If we imagine this scenario in the reverse order, that is the value is of theta is increasing gradually, and if it becomes 90 degrees, then B coincides with A. Okay, then AB equal to 0 and BC is equals to AC and both are equal to R. Okay, now sin 90 degrees. According to this triangle ABC, sin 90 degrees is equal to BC by AC. That is opposite by hypotenuse, BC by AC. BC becomes R and AC is also R. So sin 90 degrees is equal to 1. And in this way, we can find all the trigonometric ratios. Okay. Cos 90 degrees is equal to 0. Tan 90 degrees is equal to undefined. Cosec 90 degrees is equal to 1. Sec 90 degrees is equal to undefined. And cot 90 degrees is equal to 0. Okay, students. So in this way, we can find the trigonometric ratios for different specific angles. So abstract of all the trigonometric ratios that we have find here, the table represents it. So in the first row, the angles are given, and in the first column, trigonometric ratios are given, and the values of trigonometric ratios for different angles are like this. Sin 0 degrees is 0, sin 30 degrees is 1 by 2, sin 45 degrees is 1 by root 2, like this. Okay. Students, you must remember all these values to solve the problems. Okay. If you don't know or if you don't remember this table, then we can find these values in a tricky manner. Let us see that manner. Okay. So starting from 0, right? 0, 1, 2, 3, 4. Now divide all these values by 4 like this and take square root for all these fractions. Now simplify the fractions inside the square root as much you can. 0 by 4 equal to 0. 1 by 4 is in simplest form. 2 by 4 equal to 1 by 2. 3 by 4 is also in simplest form. And 4 by 4 equal to 1. So we got root 0, root 1 by 4, root 1 by 2, root 3 by 4, root 1. And we know that root 0 equal to 0. Root 1 by 4 is equal to 1 by 2. Root 1 by 2 is equal to 1 by root 2. Root 3 by 4 is root 3 by 2. And root 1 is 1. So these are the values in first row. These are the values for different ratios of sine, different angles of sine. Sine 0, sine 30, sine 45, sine 60, sine 90. Okay. In this way, we can find first row, and by writing these values in reverse order, we get the trigonometric ratios for cos, like this: 0, 1 by 2, 1 by root 2, root 3 by 2, 1. These two lines are quite different in opposite order. And now, by dividing first numbers in first row by numbers in second row, we get third row. 0 by 1, 0. 1 by 2 by root 3 by 2 is 1 by root 3. 1 by root 2 by 1 by root 2 is 1. Root 3 by 2 by 1 by 2 is root 3. And 1 by 0 is undefined. Okay. So, students, we got the values for tan also. So, and by writing multiplicative notes of all these values, we get cosec, we get the values for cosec, sec, and cot also. Okay. So, that's all for today. And we are going to solve the problems in exercise 11.2 in next class. Until then, bye. See you in next class.